Assalamualaikum and very good morning to my first panel, Sir Hafiz bin Sarkawi, and my second panel, Sir Saifullah bin Salam. Okay, my name is Muhammad Taufik bin Bahan, and my course is Bachelor of Electronic Engineering Technology, Industrial Electronic with HANA. My supervisor is Sir Hamad Nizam bin Muhammad Johari. My co-industrial supervisor is Sir Amiruddin bin Zahamail from Siemens company. Today I will present my final year project is mainly about development of IoT based control and monitoring virtual sorting machine using PLC.
Okay, I will proceed my presentation via poster. Okay, as I mentioned before, my title project is Development of IoT based control and monitoring virtual sorting machine using PLC. Okay, for the project description, this project will be designed and simulated by using virtual factory software that link to the virtual PLC software. Further, the integration of Internet of Things IoT will be implemented. Therefore, the overall equipment effectiveness OEE analysis will be performed to analyze the output ratio of the machine performance. Okay, next for the problem statement is firstly sorting machine are incapable of incorporating flexibility into their design concept. Then second, the running machine may even fails and the failure cannot be monitored. Then lastly, there is lack of productivity on a machine. For the introduction, the automated sorting machine developed allows for a lot of flexibility such as separation of metallic and non-metallic objects by push out the objects automatically to the collection bin as defined in the programmable logic control PLC regulation with a capacitive proximity sensor and inductive proximity sensor to detect a texture of the objects. Okay, for my objective in my project is to design and develop programmable logic controller PLC to control the behavior product sorting machine in virtual factory environment based on real implementation. Okay, next to the develop Internet of Things IoT based monitoring system for the sorting machine, and lastly to analyze the output ratio of the machine performance process performed in a predetermined cycle time. Okay, for the methodology, this is my project design that I designed at the Factory IO, which is the virtual factory software. This is just like a real machine implementation. So what we can look at here, they have like a real conveyor and real solenoid actuator, solenoid valve that push the metal and or non-metal object to the collection bin. And this is my flow diagram, which is firstly is the virtual controller, then go to machine, then go to virtual IoT gateway, and then integrate with smart device and web base. So firstly is the TIA portal will be linked to the PLC SIM Advanced as the virtual controller of this machine, then integrate with virtual factory, which is the Factory IO, which is this design, act like a real machine. Then go to the virtual IoT gateway, which is Node-RED IoT web server platform. Then it will send data to controlling and monitoring the machine process via Blink apps and Node-RED dashboard. This Excel is to log OEE data that produced by the machine in 5 minutes. Okay, this is my flowchart. Firstly, start, then develop the machine on Factory IO. Then next, develop the ladder diagram on TIA portal. Then download and simulate the program at TIA portal through PLC SIM Advanced. Then the Factory IO will connect with the PLC SIM Advanced. So when the connection is successfully, the virtual machine at Factory IO will be simulated. Then if no, it will back to the develop the ladder diagram again. Then if the machine running with correct sequence, the IoT web server can be debugged. If not, go back to the develop ladder diagram on the TIA portal. So when the IoT is already successfully debugged, the test the connection node rate with the PLC SIM Advanced and the factory I/O. If all the software the F connection, which is PLC SIM Advanced, TIA portal, and IoT web server, so collect and analyze the OEE data. If connection not successfully, go back to the IoT, debug the IoT web server. Maybe cause from the flow nodes from the IoT or the programming at IoT. Then end the project. Okay, for the result and discussion, this is my Blink apps and factory IO and Node-RED. Okay, then when the start PB is pressed, the Blink apps shown the display green light, and factory IO also green, so the green light will be turned on, and the at Node-RED the green will be turned on. Then for the stop PB is pressed, the Blink apps will show the red light will be turned on, and same with factory IO as well as the at Node-RED dashboard. Okay, this is the OEE data that developed at the Node-RED dashboard. Okay, this is the treatment to find the availability, performance, and this is the quality. This is the percentage of the availability and percentage of the performance and quality. Then this is the OEE percentage. This is OEE percentage versus time second that I take, which is 92.1%. This is my major percentage losses, which is consists of system downtime, actual production, and defect. The main defect for the OEE percentage is system downtime, which is 5.67%, then followed by actual production, which is 2.37%, and defect is 0%. Okay, next for the project features. Okay, this project act like a real machine implementation. So when the real machine has been developed, all the program just download to the real PLC. Okay, for the creative and inventiveness of this project is, this project has been integrated with IoT, which will be allowed the machine process to monitor and control via smart device. Then for the project potential is, this project can easier to the company of PLC trainer such as Siemens company, as well as for educational, because the learning process can be proceed without the real machine. For the conclusion, in a nutshell, there are three main designs that has been developed with successfully, which is virtual machine, virtual controller, and virtual IoT gateway via the virtual software. Besides, the analysis is already done by interpret the overall equipment effectiveness OEE analysis into the design. Okay, we start to the project demonstration. Okay, firstly, open the TIA portal is Siemens software. Then open PLC SIM Advanced. Then start. So this is the IP address for the PLC, and then download the program. This is the all program. Okay, just go online. Okay, this will go online automatically when this is the indicator give the green light, so all the connection is successfully downloaded to the PLC SIEM Advanced. So then next open the Node-RED CMD to run the Node-RED. Then next open the Node-RED web server at the browser, which is the run at 127.0.0.1, the IP address. So as you can see here, all the parameter has been connected with successfully. So then we go to the factory IO, then select the driver to select the Siemens S7 1500. Just connect to the PLC, and this show the connection is already successfully. So we run simulate the factory IO. So this is the design. This is initial condition. Okay, this is the machine process, which is the non-material will be stored at here, and the metal material will sort at here. So after five product has been sorted in this box, the box will go to the last end process, which is remove the box. So we can look at the blink application also. The green light same with the factory IO, and also same to with the Node-RED dashboard. Node-RED dashboard. So it will show the red light, and it blink also red light, and at the factory IO also the red light. So all the connection has been successfully connected. We also can stop the machine, which is stop. So the machine, all the progress will be stopped, and we can start back. The machine will run continuous with the previous step. Okay, we proceed to the OEE data. So OEE data, we can open availability percentage, performance percentage, and quality percentage, and OEE percentage. So this is the main effect to the availability and performance, and this is for the quality. This is the system downtime, which is 29 seconds, and this is the planned operation time, and this the availability percentage, which same with here. And this the for the performance, this actual run rate, this is 272, which is planned operation time minus with the system downtime. And this the actual production for right now. The value is still changing because the machine operation still turn on. So the machine is already turned off, so it means it's all achieved the 5-minute duration time. So the performance, we get the 98.75%, and the quality is no defect. So the quality is 100%. So we can get the OEE value, which is 89.24%. So we proceed to the OEE data. So this is the OEE data that has been logged at the Excel format from the Node-RED web server that saved to my computer, and this is the data for 5 minutes duration. So this is the time. So we can look here, 300 seconds is equal to 5 minutes duration. So this is the parameter that want to log the data. and this is availability, performance, and quality percentage. Okay, last we proceed to the WinCC Unify, which is to monitor the temperature surrounding and the leaking of gas at the factory. So just start the simulation and load. The simulation is already run at this schematic runtime manager, and open the browser, find the local host, WinCC Unify localhost, and click WinCC Unify RT. Then this is the temperature sensor. This is the gas sensor. This is like analog sensor input, and this is also for the gas analog input. So analog is for just like that. The value from analog is red, so the temperature is 45%, so it give a warning. If less than 40 degree, it will display good. Same with this gas sensor. If the analog sensor read more than 40, so it give warning. If less than 40, it will display good. Okay, I think that's all for my final year project presentation. Thank you very much.